Welcome to this code demonstrations and explanations for question 1C, program 1. So I'm going to walk you through the program that calculates the parameters of two distinct hexagons and sum them together. So the core challenge of this task is to find the parameters strictly using a loop and add architecture rather than relying on direct multiplications instructions. So as you can see, at first, we declare our variables as 32-bit unsigned integer using the dword directive. So which are site hexa1 and site hexa2. They will hold the user input from the keyboard. Yeah. So the parameter hexagon1, parameter hexagon2, and total parameter are uninitialized memory slot uh, ready to store our calculated results. And below that, we have uh, we have our now terminated byte string, as you can see here. So these text prompts are formatted precisely with comments and zeros at the end to match our assignment required console display layout exactly. And next, we transition into the uh, execution zone marked by the dot code directive and our main procedure block. So in order to interact with the user, we have to look at how assembly manage text printing. So the CPU requires the starting memory address of a string to be loaded into a specific register before printing. Therefore, we use the instructions move edx offset main title. This put the memory locations of our text into the edx register, and then we involve call write string, which read the edx and print out our text to the screen. So for the instructions, call crlf is then used to move our console cursor down to a fresh line. Alright, so to actually capture the numbers from the keyboard, we call read decimal, read dec, right? So these functions basically is to pause at the executions and wait for the user input and automatically store the resulting 32-bit unsigned integer into the EAX register, which is our primary accumulator. Then we immediately move the site hexa1 EAX to copy that value out of the CPU register and safely into our RAM variable. And then we repeat the same exact sequence to capture the second hexagon side length. Alright. And then uh, let's come to the heart of the assignment, calculating the parameters without multiplications. So because a hexagon has 6 equal sides, side, so we must simulate the multiplications by adding the side length to a running total exactly 6 times. So to accomplish this, we use the ECX register, which is the dedicated hardware counter register for looping operations. So we execute move ECX 6 to establish our 6 loop cycles. Next, we use move EAX 0 to completely flush out the EAX register so no leftover data collapse our math. So inside the code block, label L1 L1. We execute add EAX site hexa1. This updates our running total in EAX. So right after the loop L1 instructions take over. So behind the scene, the CPU automatically decrements ECX by 1 and check if it has reached 0 or not. So if the EAX is greater than 0, the CPU performs a conditional jump right back up to the L1 levels. And this cycle repeats exactly 6 times. So once the ECX hit 0, so the loop will be broken, and we save the finalized parameters into parameter hexagon 1. And yeah, so and then we repeat the identically architecture under the L2 as well for our second hexagon. Alright, so with both individual parameters secure calculated, we need to add them together. So we move our uh, first parameters into EAX and then move, and then add the second parameter variables directly to EAX and save the combined sum into total parameters. So to conclude the program, we call uh, we call write decimal, write DEC to output our final results. Right, so let's run the program to see uh, in actions. Right, all right. So if I input 21 for hexagon 1 and 32 for hexagon 2. So you can see, okay, right. So you can see the program successfully outputs 126 and 192 and a combined total parameters of 318. So it perfectly matching our target output screenshot. Yeah, I think that's all for my video. Thank you.